So remember, we're graphing rational functions. What makes it rational is there's an x in the denominator. And let's practice what we learned last time, because this is pretty much more than half of your test is graphing rational functions. So right here we would say, okay, factor the top, factor the bottom. In this case, they gave you one that's factored. Sometimes they'll do that. And then I would look at my vertical asymptotes. They come from the bottom. So vertical asymptotes are at x equals -1 and at x equals 5, right, everyone? Yes, yes. Okay, so when we go to graph this, we're going to draw in, let's just jump down to the graph and draw in -1 and 5. Now that's really not enough. That's not enough information. We need to write whether it's gonna go in opposite direction or the same direction. So at x equals -1, since it happened one time, see it only happened once, it's gonna go in opposite directions at the asymptote. And at 5, same thing happened. It only happened once. X equals 5 happened once. So we're gonna write ourselves a note opposite. That's going to make a huge difference in how quick you can graph these. Like I said, there was a teacher that's a professor at UVU that was like, hey, did you even know this happened? And I'm like, yeah, I did. I actually only figured it out though a few years ago, and it's a game changer. Okay, horizontal asymptotes are end behavioral asymptotes. We know vertical asymptotes are never crossed because they're domain restrictions. So if they ask you domain, I mean, it's everything but -1 to 5. So our domain would be -infinity to -1, -1 to 5, 5 to infinity. So yes, those never get crossed because they're domain restrictions, but horizontal are not domain restrictions. Horizontal asymptotes only guarantee that your graph will approach it clear out to the left and right. So the middle, that horizontal asymptote isn't helpful for. Now remember, for horizontal asymptote, you don't want it in factored form. You want it in standard form, and you don't need to distribute out the whole thing. We just do we just figure out the front term. So it'd be 3x squared on top. And on bottom, we have an x times x, which is x squared. We know if we're plugging in a billion, the leading term is so much larger than everything else that it's the only thing that matters, right? Since these are the exact same power, don't they divide out perfectly? Yes? Giving us 3. So y equals 3. It may or may not cross the horizontal asymptote. We don't really know. It doesn't really matter. We're doing a rough sketch here, so that just doesn't matter. Okay. All right. Now it does shape our graph to the far left and right. We know we're going to approach it to the far left and right. Now all we got to do is get started. And so I recommended some easy points, which are x-intercepts and y-intercepts. X-intercepts are when we set it equal to 0. So we have 0 equals 3 times x minus 2 times x plus 3 divided by x plus 1 times x minus 5. Now, what would we do first to solve for x? Multiply the bottom up. That's why I always say if the first step is to multiply the bottom up, the bottom will always be multiplied to 0 if we're finding x-intercepts. So we really just never need to write the bottom in. It's kind of silly to write it in. And now we would just solve the top, and we want the top factored to solve, because solving by factoring is the easiest method, and it is already factored. So then we set each factor equal to 0. If you set 0 equal to 3, you can't even solve. That's a contradiction. So that constant doesn't affect solutions. 0 equals x minus 2, 0 equals x plus 3. We'll then solve for x, so we're adding 2. 2 equals x. So we're going to write 2 comma 0. Now that's not enough information, you guys. It really isn't. You've got to keep this in your head. X-intercepts can bounce or cross, and that totally changes the graph. Is this x-intercept going to cross or bounce? It is, because it only happened one time. If it happened twice or 4 times, we would know it bounces. If it happens once, 3 times, 5 times, it's going to cross through. Subtract 3. X equals -3. So -3, 0 is another point on the graph. And because it happened once, it's going to cross through. I'll go graph them in, I guess, red. So what I already forgot, it was -3 and 2. So -3, -1, 2, 3 is right there. And we know it's going to cross through. And 2, +2. Okay. All right, now y-intercepts are just another point to kind of help you. Y-intercepts are when x is 0. So this time we have to go plug in 0. So that would look like this. 3 times 0 minus 2 times 0 plus 3 divided by 0 plus 1 times 0 minus 5, which then you just have to be smart enough to calculate something like this, which we all are. We just got to not overthink it. Wouldn't that just be 3 times negative 2 times 3 on top, everyone? Look, 3 times negative 2 times 3, right, everyone? 0 plus 3 is 3. 0 minus 2 is negative 2. You with me? Then on bottom, we would have a 1 times negative 5. So I'm just going to do a decimal. For graphing, decimals make more sense in my brain. So I'm doing 3 times negative 2 times 3. And then I'm dividing it by negative 5. And that's 3.6. So when we plugged in 0, we got out 3.6. So there's another red point over 0 up 1, 2, 3.6.
Get when Cedar to the attendance office for just a minute?
Yes. Go ahead. Okay. All right. So now that we have these points, the question is it enough for you to feel confident? Now, here's the key, you guys. We can only cross the x-axis in these 2 red points. You can't cross anywhere else. So let's think together, okay? I personally like to start on the right side of the vertical asymptote. So if I'm starting on the right side of the vertical asymptote, we know the asymptote shape us. So we're either going to be coming, let me draw the 2 scenarios in green if you don't mind, or I'll change up the color so we can communicate. Either it's going to look like this, or, because asymptote shape, or it's going to be purple and look like this. Both don't work in this scenario. Sometimes both, it's like actually either could work. But does purple or green work here? Purple, of course. Doesn't green cross the x-axis? Well, you can't just cross the x-axis at any old random Joe Schmo place. So green is not possible. So let's erase green. Now, don't get tempted. I used to get tempted to then go to points. Don't go to points. You're going to confuse yourself. Always, once you have one side of the asymptote drawn, start by drawing the other side of the asymptote. So since it's going in opposite direction, you're going to jump to the other side of the asymptote and you're going to go down because we said opposite. You guys see how I draw my arrow down? Yes? Now from here, you're going to start tracing. Now we're going to head to the red points. The red points are part of the graph. So here I am. I'm coming up, starting down here at the arrow, and I'm tracing, and I know I'm heading to the x-intercept. Now, if it bounces back down, cool. If it crosses through, cool. Which one is it? Cross through. Now think about where you're headed. Aren't you headed to the next red point? Don't be weirded out that there's a blue asymptote. That doesn't help us in the middle of the graph. So I'm like, okay, blue, don't let my brain think it matters because it doesn't. And then I head up to this asymptote. Once you have one side of the asymptote drawn, always start by then drawing the other side of the asymptote. We said opposite. So we jump to the other side of the asymptote and we know we're going down. Is everyone agreeing with that? And now you just start the tactic of tracing again. So you're going to go, okay, I'm down here and I'm tracing, and I'm headed to the red point. And do we bounce or cross? We cross through, which means we're headed to our asymptote. Now, what if I decide to cross the asymptote? Is that okay? It is, but what do I have to make sure I draw at the end? It coming back down. So what if I would have not crossed the asymptote? What if I just would have went like this? Isn't that fine as well? It is. We don't know if it crosses or not. I don't know. It doesn't matter though, because we're just drawing a rough sketch here. So I'm going to look and say on the test, is this person's graph headed in the right direction to the very far left and right? Yes, so it doesn't matter if they crossed it or not. So somebody on yesterday's was like, so what if I went like this? I'm like, sweet, go for it, because we don't know what it's doing there. You know what I mean? And it doesn't matter. Okay, awesome. So let's move on to just adding in what we need to do today. So they're going to use the word discontinuous. Discontinuous. So graphs are discontinuous if there is a gap or break or hole in the graph. So vertical asymptotes create a discontinuous graph because look at these right here. If this is a vertical asymptote right here, and it is, then the graph is discontinuous there because we can't cross. Don't we have to then like lift up our pencil to start again graphing? So that makes it discontinuous, right? Where the vertical asymptote is, it breaks up the graph. You can't connect all the way left and right. Now there's another discontinuity, something else that makes our graph discontinuous. So we're now going to see that not only vertical asymptotes create it to be discontinuous. See, it is discontinuous. It doesn't connect from left to right perfectly. There's also holes. Now look, discontinuous means you have to pick up your pencil. So if you guys look right here, I have this hole at 3, 2. when I trace down, don't I need to pick up my pencil to then start again? Do you guys see what I'm saying? So that's another discontinuity. So there's actually not just one type of, like I said, one type of discontinuity. It's vertical asymptotes or holes. Last time we didn't see any holes because they were just like, let's just start without holes and then let's throw in holes. So look, this is discontinuous at the vertical asymptotes, everyone. And isn't there 2 holes? Yeah? Now notice the holes aren't floating in the middle of nowhere. Aren't the holes part of the graph? Do you guys see? Look at all the holes. So it's actually really helpful if there's a hole because that's just one more point. Just like X and Y intercepts are really easy to find, holes are also pretty easy to find. And it just gives you an additional, basically, graphing tool because that is a point on the graph. So you should never have a point. Look, I always have students when they're new at this, at least as like juniors, drawing a hole in the middle of nowhere. They should have known their hole's messed up or their graph's messed up. There's not going to just be a floating hole. Do you guys see what I'm, like, the hole is not really there. Basically, I could erase the hole, watch. They do it for dramatic purposes and it could look like that. You guys see what I'm saying? Like, that's just where it stops and then it jumps over and starts again. So you'll never have a hole floating in the middle of nowhere. There's not even anything there then. So make sure you guys understand holes are XY points. See, XY points, which makes sense. So we're going to be able to find the X value of the hole. Then we'll have to go find the Y value of the hole. See, XY. And that will just give us more tools in the toolbox to graph. So where are we going to see a hole and where are we going to see a vertical asymptote? So let me rephrase. I need everyone listening so you're not confused. Didn't I say last time vertical asymptotes come from the bottom? That's true, but holes are on bottom as well. So how are we going to know if it's a vertical asymptote or hole? Well, it's actually really simple. Vertical asymptotes are restrictions. Let's write out the restriction, x equals 1 and x equals -7, that don't divide out. So think about it. If something divides out, that means it was also listed on top. So look down here. Do you guys see how our restrictions down here are x equals 2 and x equals 1? But what happens with the x minus 2's? They cancel out. So when something cancels out, remember, we always do domain restrictions before simplifying. So that's why that's still a domain restriction. We write in restrictions before we simplify. So now we removed this discontinuity. So removable discontinuities create holes. So this would be what you would do. You would say, okay, is this a vertical asymptote or hole? Well, does x minus 1 divide out? No. So it's a vertical asymptote. Does everyone see what I'm saying? Is -7 a hole or vertical asymptote? Well, does x plus 7 divide out? Then it's a vertical asymptote. So you would have a vertical asymptote at 1 and at -7. Okay, but look right here. Once again, you would say, okay, restrictions are vertical asymptotes or holes. This is a hole, right, everyone? Because x minus 2 divided out. Now, a hole is not good enough. You can't just say 2. It's like 2 comma what? So what you're going to do is state the restriction, and then you're going to write down the new equation. Isn't our new equation x plus 3 over x minus 1, everyone? And for the rest of the problem, you're going to use this simplified thing. You're no longer going to go back to the original ever again. So now if I said to you the hole's at 2, it's really not just 2. You can't do 2, 0. It's not 2, 0. It's 2 comma some number. So to find the number, you go plug in 2. Make sure you plug it into the simplified function. If you plug it into the original, wouldn't it be 0 divided by 0? You can't, or it would have been, yeah, 0 divided by 0. You can't divide by 0. You cannot plug it into the original. You have to plug it into the simplified function. So you would say 2 comma 2 plus 3. See, I'm plugging it in. Divided by 2 minus 1. So that's 2 comma, isn't that 5 over 1? 2 comma 5 is the whole. Does that make sense? And then x equals 1 didn't simplify out, so it's a vertical asymptote at x equals 1. So they call them removable discontinuities and non-removable. Removable means they remove. They divide out, which would be a hole. Non-removable means literally they don't divide out. It's very literal, which means it will be a vertical asymptote. Okay, so let's practice one with a hole. It's not any harder. So they just say on the test graph. So you would say, I'm going to factor the top, factor the bottom. So we have an x plus 3 on top. I'm going to use parentheses. And on bottom, x squared minus 9 factors to be x plus 3 and x minus 3. Do not divide out the x plus 3's. You have to state vertical asymptotes and wholes first. So when you look at x plus 3, is it a vertical asymptote or whole? It's a whole because it removes. Now you're going to say x equals -3. Make sure you don't accidentally say, it's a common error for people to say 3. No, the restriction is -3. Do you guys see what I'm saying? So now my x plus 3's need to be removed. And you're going to write the new equation. And you're never going to go back to the original equation. You're going to use this from here on out. So you're going to say, okay, my whole is really not at -3. It's at -3 comma some y value. So now I go plug -3 into the simplified function. So that'd be 1 over -3 minus 3, which would be -3, -1/6, which is -3. For graphing, I like decimals. -1/6 is like -0.1 whole. So that's going to be a point we use just like x and y intercepts. I'll put that in a minute if that's okay. I'm going to move on to vertical asymptotes. Doesn't this not remove? Then it's a vertical asymptote, but that's not enough. At 3, we have a vertical asymptote, and does it go in the same or opposite direction? Opposite. Why? Because it happened one time. Is everyone agreeing with her? So let's go put that in. X equals 3. Asymptotes are really what you draw first because they shape your graph. So you're going to write x equals 3, and you're going to write yourself a note. Once I get started, it has to go in opposite direction. Now we still do everything else like normal. Now we do our horizontal asymptote. Never go back to the original. Can you? Yeah, but just don't. Like, just use the new function. Here's our new function. To find horizontal asymptote, we do leading term divided by leading term. What's the leading term on top? 1. What's the leading term on bottom? X. 1 over x doesn't divide out to be a number. So the question is, well, what is it? Is it horizontal or not? So if we plug in a billion, isn't it 1 divided by a billion? Why am I plugging in a billion? Because a billion's really far out to the right, and I am literally just saying, what is the y value calculate really far out to be? So what's 1 divided by a billion? Pretty much 0. So you're going to write y equals 0. Go draw that in. Now, don't be that person that says, oh, so I can't cross that. No, sometimes horizontal asymptotes are crossed and sometimes they're not. It just depends. Not going to. It just depends. We now move on to, let's get some points going. Well, don't we already have 1 point, the whole? Let's go put it in. Maybe that's all we need. Maybe we don't even have to do x and y intercepts. Let's go see. -1, 2, 3. -1, 2, 3. Down a little bit and put a hole. Would you like to do x and y intercepts? Might as well or no? What do you think? Sure. So x-intercept is y equals 0. So say 0 equals 1 over x minus 3. Remember, you should be using the simplified function. Then we know we just set the top equal to 0. The bottom will multiply up to 0. So 0 equals 1. Can you even solve for x? So what do we know about x-intercepts? There is none. If you can't solve, there is none. Isn't that a contradiction? So this time, none. Do not, if you cross the x-axis, you have the wrong graph. No x-intercepts. Let's do y-intercept. So that's when we plug in 0. So that'd be 1 over 0 minus 3, which is -1/3. So we said 0 comma -1/3. Well, there's another point on the graph. Over 0, down -1/3. Okay. All right. Now, if I try to start on the right side of the vertical asymptote, I don't know where it's at. Couldn't it be up there or down here? So I'm going to choose to, for like this time, I'm going to say, let's start on the left side of the vertical asymptote because I have some points. Won't the pink points connect, everyone? So start there. Connect them. And then asymptote shape. So where are we headed to? The asymptotes. So wouldn't it make sense that it's coming to this asymptote, everyone? Yeah? And then isn't it headed to this asymptote? And we know it's not crossing the x-axis. Now, because we know we're going in opposite direction, once we have this side of the asymptote drawn, we should start by jumping to the other side and going in opposite direction like that. That's how we start. And then we just do our tracing. So we say, okay, if that's how we're started, we're then tracing an asymptote shape. So I'm looking like that. And that must be my graph. So you can see it wasn't anything harder. It's just now you have to like draw in a hole if there is one. Which actually is almost kind of helpful because it gives you an additional point to help connect the dots. Questions? You gotta ask questions. Okay, let's do slanted asymptotes. We did talk about it last time, or we even saw last time we talked about there could be a quadratic asymptote. Basically, non-horizontal asymptotes. We just didn't, we talked about it at the beginning, and then none of the examples had them. So, look right here, for example. Remember, if we're doing horizontal asymptotes, we do leading term divided by leading term, which would be, in this case, x, right? Isn't x not the same as 1 over x? We know 1 over x was 1 over x versus 1 over x. Wasn't this one 0, everyone? But this one, when you plug in a billion, what do you get out? A billion. When you plug in 100, you get out, we're plugging it in right there. We plug out 100, we get out 100. When we plug in 1, we get out 1. Isn't that creating a line? Which makes sense. Isn't x to the first linear? Okay, so you're going to say it's a line. That's not good enough. So what you're going to do is say, what is the line? So we're going to do synthetic division. We're going to set x minus 3 equal to 0. We're going to add 3. This is how synthetic division works. We know that because we learned it in 1010. And then we've relearned it in 1050. So we put these coefficients in from our quadratic, 1, -4, -5, and then we add straight down. Multiply up, add straight down, multiply up, add straight down. Isn't the final thing the remainder? For graphing purposes, we actually don't need the remainder. We just ignore it. I promise you don't need it for graphing. So then what are we dealing with here? A line. What's the line? Those are the coefficients. Y equals 1x minus 1. Now the question is, do you know how to do 6th grade math? Isn't this y-intercept, everyone? Yes, that's how lines work. Everyone with me? So I go down to -1. And then what's the slope? Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so on and so forth. So you can see that's where they're getting this slanted line. Does that kind of make sense? And it shapes your graph. Look, see, as you go far out to the right, isn't that dotted line where it's approaching? To the right and to the left, isn't it where it's approaching? So it's the same, it works the same as a horizontal asymptote, but it's going to guide our graph. Okay, cool. All right, so let's just get to the point here. You can see, oh, there's a slanted asymptote. There's a slanted asymptote. The key is noticing, does the slanted asymptote really affect the middle of the graph? No, it just guarantees to the right and to the left, it's going to approach that dotted line. See, clear out here to the right and clear out here to the left. It's approaching the dotted line. It doesn't really help you shape the middle. All right, let's go do one that just happens to have a slanted line. Okay, so you wouldn't know it till you get going. So we're going to factor the top. A times C adds up to be B. Well, multiplies to be 3, adds up to be -2. We know it'll be 1 times 3, I believe -3. Now careful, because does this quadratic quick factor? No. So let's do the correct way of factoring. We write 3x squared and we write +1 because we write our n terms in, and then we're rewriting -2x as these with an x. So -3x plus 1x. We're then grouping. This is how we factor quadratics. Pull out a 3x, divide by 3x, divide by 3x. So left will be x minus 1. I must have messed something up. I know I did. Want to know why? Because look, when I pull out +1, isn't it x plus 1? It's not the same. So I'm like, either I picked the wrong factors or I've messed up. And I look back and I'm like, I didn't mess up. So I must have picked the wrong factors.
I think you made when you were factoring out for 3, you made negative instead of positive. It's like under the AC.
Yes, that's exactly right. This is exactly right. She's making a good point. Does it actually work? Is 1 times -3 +3? So it doesn't factor. I was going too quick, right, everyone? Do you guys agree? It doesn't factor then. It doesn't work in both cases. Oh, so I go, whoopsies, never mind. It doesn't factor. Well, if it doesn't factor, then I'm good. I'm like, okay, if it doesn't factor, then it doesn't factor. You know what I mean? Like, it's not going to divide out the bottom, right? It would factor if it was going to factor. So we're going to assume that it doesn't divide out with the bottom, or else it would have factored. Okay, so now we'll move on to vertical asymptotes and holes. Now it's no longer vertical asymptotes, it's vertical asymptotes and holes. Is this bottom a vertical asymptote or hole? Does it divide out or does it not? If you did the quadratic formula, you're going to have imaginary and irrational solutions, so you would be kind of wasting your time because it's not going to divide out with the bottom. And that's really what we're trying to find, right, is if it divides out with the bottom. So again, that's a great question, and maybe we'll do it if we want x-intercepts bad enough, but I avoid it, you know what I mean, if I can. Okay, everyone, I'm asking, is it a vertical asymptote or hole? It's a vertical asymptote. How does she know that, everyone? It doesn't divide out, or it would have factored. So you're going to write yourself a note, there's no holes. Okay, that's fine. And this isn't enough. You can't just say, is it a vertical asymptote? You have to say, but does it go in the same or opposite direction? Doesn't it happen one time? So it goes in opposite direction. Literally, this isn't squared. That would be happening twice. I was trying to answer a question, but it's fine. He doesn't care. So x equals 1 goes in opposite direction because that restriction only happened once. Okay, moving on. That's not enough to graph, not even close. Horizontal asymptote. You do leading term divided by leading term, which is 3x. Oh, isn't that linear? So you'd say, okay, not good enough, not good enough. It's actually not horizontal, it's linear, and we have to go through and do synthetic or long division. Because the bottom is linear, and leading coefficient of 1, we're allowed to do synthetic. So set x minus 1 equal to 0 and add 1. X equals 1. We then put in coefficients 3, negative 2, 1. We all know how to do synthetic division. We're going to add straight down, multiply up, add straight down, multiply up, add straight down. Isn't the final thing the remainder as long as I set it up correctly? I don't need the remainder for graphing. So what's the line? Y equals 3x plus 1. Those are coefficients. So this is the y-intercept. This is how lines work. So go up to positive 1. Put your dot. This is our slope. We know that this is how lines work. So you're going to go up 1, 2, 3 over 1. It's rise over run. Isn't 3 over 1? Really? Rise over run, my friends. We all know how to graph a line. This is why we took 10, 10, so in this exact moment we wouldn't be confused. Everyone with me? You all good? So rising 1, 2, 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1. And then I draw in, and I'm going to erase this wording because I like dramatic. I think it's less confusing if it goes dramatically past. Like I like to see, I don't like it to be really squished. So I'm going to kind of make these a little more, big like that. Okay, now we got to get started, and we can't get started unless we have a point, and we didn't have a hole, so we don't even have a point. So we got to get some easy points. So let's do easy points. Our x-intercepts when we set the top equal to 0. We already know it doesn't factor. So do you want to do the quadratic formula or nah? Then you don't have to. Let's see if there's different points that are more convenient. So I'm like, no, thanks. Because couldn't it be decimals, everybody? But I'm like, nah, that's a pain. Let's do y-intercept. That's when x is 0. That one's always easy. So if I plug in 0, I'm getting on top 3 times 0 squared minus 2 times 0 plus 1 divided by 0 minus 1, which is 0, comma. On top isn't it 1, and on bottom isn't it negative 1? Mm-hmm. So that would really be 0, negative 1. 0, negative 1 is the y-intercept. Okay. So asymptote shape my graph, right? So that should be enough to actually graph this, because I should be headed to my asymptote, headed to my asymptote. Can I cross a vertical asymptote? No. Could I cross the slanted one? Yeah. Doesn't matter as long as I head back to it. Now, if you don't have people go, I don't know what to do next. Yeah, you do. It's opposite. It's opposite. So if it's down right here, where should it be up here? Up like that. And then from there, you just trace an asymptotes shape. So wouldn't it look like this? Does that make sense, everyone? That does connect from left to right forever. I always have a kid saying, well, there's a, like, this should be, it should be, the domain should be from negative infinity to 1 to infinity. It is. Isn't it slowly growing this way forever, everybody, to the left? And isn't it then slowly going right forever? So yeah, it's good. We're good. Looks good. Okay, good. Let's do another one. Oh dear. How do we, oh dear. They're being mean to us here. How should we try factoring the top? Grouping? Right, everyone? Mm-hmm. And then grouping doesn't work. So then what do we have to use? Eye twitch. If grouping doesn't work, how do you have to factor it? This isn't quadratic, but I like that you're trying. Look, it's power of 3. Oh, you could try long division if you wanted. It's not a bad tactic. We learned a method, another method when all factoring fails. Anyone? No, because that was with matrix. That was with linear stuff. But I like that you're trying. It was P over Q. Remember? P over Q is a factoring technique. It's just our last choice. The rational root theorem. Do you guys even know what I'm talking about? Okay, so you would say P is the constant, Q is the leading. Now, why am I going to these lengths? Because it might factor. If it's quadratic and it doesn't factor, I know it doesn't factor. If it's cubic and doesn't factor, that doesn't mean it really doesn't factor. It means we might have to use P over Q method. Do you guys see what I'm saying? Yes or no? Okay. So here we go. Let's list out factors of P. Plus and minus 1. Plus, oh, that's it. Plus and minus 1. Did I do that right? P and Q? Yep. Plus and minus 1. My bad. Okay. Then Q. Factors of 2 are plus and minus 1. Plus and minus 2. So P over Q. We do P's divided by Q's. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. So I'm going to start testing with synthetic division. I'm just looking at the top right now, remember. I'm just focusing on the top. So then I put in coefficient 2, 5, 4, 1. We're looking for a remainder of 0. Wait, I better make sure I'm not missing anything. 3, 2, 1, constant. Okay. Add straight down, multiply up. Add straight down, multiply up. Add straight down, multiply up. Is the remainder going to be 0? I can see it's not going to be 0. Do you guys see what I'm saying? So I'm like, okay, it's not 1. Let's try negative 1. 2, 5, 4, 1. Add straight down, multiply up. Add straight down, multiply up. Add straight down, oh, it does freaking factor, doesn't it? Yes, everyone, remainder 0. So you're like, okay. So, careful though, it's x equals negative 1 is a solution. Let's find the solutions and then work backwards to the factors. So it's negative 1 is the solution. So now we have a quadratic because it used to be power of 3. We just divided it down once, which means it's now power of 2. So write 2x squared plus 3x plus 1. Now let's see if we can factor it. A times c adds up to be b, unless you want to keep testing, but most of the time that's going to be a no for me. What multiplies to be 2 adds up to be 3, 1 and 2. Negative 1, no, positive and positive. I don't know what I'm thinking here. I'm going to double check that before I move on this time. Yes, it actually works, and I've got a long factor, so I got to drop these down. Drop down 2x squared, drop down positive 1, and then rewrite 3x as plus 2x plus 1x. I actually really like this problem because it does take an advanced level of understanding in your math, which is a good thing. So then I pull out x plus 1, and it looks like 2x plus 1. Now, do I need the solutions or the factors? Aren't we like trying to get the factors, everyone? So I'm like, I'm not even going to find the solutions because I'm looking for the factors. Now, careful though. Because we should have 3 factors if it's degree 3. So let's rewrite the problem. What is the top factor to be? Well, there's 2 of the factors. What was the other factor? It was actually x plus 1, which we already had 1x plus 1. So I'm going to put x plus 1 squared. Because if you add 1, the other factor would have been x plus 1. Do you guys see? Okay. And now the bottom is a quadratic that factors. It's, notice, what multiplies to be a times c adds up to be, what multiplies to be 2 adds up to be 3, 1 and 2, 1 plus 2, and it factors just the same. It quick factors, this one does, so x plus 1 and x plus 2. Right? Does it quick factor? Okay, yeah. Oh man, this one's a good one. There's a lot of weird things going on here. Just things that we don't see very often. All right. All right.
Would test be like this?
Yeah. It could definitely be, because the whole test, pretty much, a lot of the test, a huge portion of the test is just graph. You know what I mean? So they could put 1 at least this advanced. It's not like the whole test would be this advanced, but it's not too bad. You just gotta, I mean, it is, it's advanced. Let's just call it what it is. All right. So now we can find vertical asymptotes and holes. Now, you know what I'm going to do? Actually, I am going to write it out like this. X plus 1 times x plus 1 times 2x plus 1 divided by x plus 1 times x plus 2. Okay, so I'm going to look at it like that instead of squared. That's just me. So now I'm going to say vertical asymptote or hole. Is the bottom a vertical asymptote or hole? So x plus 1, is it a vertical asymptote or hole? It's a hole. If it removes out, it's a hole. Does it remove out? So you would say at x equals -1, not +1. You have to find the restriction, and it's -1. There's a hole at -1. So you would say, okay, -1 comma, to find the y value, we need to now use the new equation. And for the rest of the problem, we're going to use x plus 1 times 2x plus 1 divided by x plus 2. Dang, this one really is advanced. So now we're going to go plug in -1. So that would be -1 plus 1 times 2 times -1 plus 1 divided by -1 plus 2. See, I'm plugging -1 into the new function. That would just be 0, because it's 0 times -1 divided by 1, which isn't 0 on top okay, everybody? So 0 divided by 1 is 0. So -1, 0 is a hole. Then what's my vertical asymptote? X equals -2, and it goes in opposite direction because it only happened one time. So let's go to -2 and draw in our vertical asymptote and write ourselves a note. X equals -2 goes in opposite direction. We also have a hole. I'm going to write it down here so I can refer back to it. That's just a point on the graph. It was -1, 0. I put it in later, just once I get my horizontal and vertical asymptotes drawn. And now what's my horizontal asymptote at? Well, use the simplified function. So we do leading term divided by leading term. What's the leading term on top? 2x squared. The leading term on bottom is x. So what is that? 2x. This is basically as hard as it can get. Here's why. Isn't that linear? Okay, now here's the problem. We have to actually do synthetic or long division. I want to use synthetic division. Either way, I have to distribute out the whole thing because you can only do division with things not in factored form. So we have to hurry and distribute. 2x squared plus x plus 2x plus 1. So on top we have 2x squared plus 3x plus 1 divided by x plus 2. Now I'm set up for synthetic division. So we would set the bottom, x plus 2 equal to 0, and solve. So x equals -2. We then do synthetic division with 2, 3, 1. Do you guys see how now I'm using this to to do synthetic division right here. I'm gonna highlight it. I'm doing synthetic division with that right now. That's a 3. Okay, add straight down, multiply up, add straight down, multiply up, add straight down. The final thing is the remainder. I don't need it. So what will the line be? 2x minus 1. We then will do y-intercept at -1. And our slope is up 2 over 1. Rise over run. So up 1, 2 over 1, 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 down 1, 2 over 1. And I do mine dramatically past. Like I said, when it gets squishy, like right here looks squishy, I go like past so it's a little less squishy. Okay, and now we need to get some, oh yes?
Why on this one is it you from horizontal asymptote, you can't just do leading term over leading term?
We did.
And you
Yep. Leading term divided by leading term was 2x, which is linear. It's not a number.
It's
It's slanted because the line's slanted.
yeah.
It would have been nice if it would have been like 1 over 2x because that's different. That would be 0. You know what I mean? 1 over 2 billion. One piece of bread cut into 2 billion people. No one's getting bread. If we would have had 2x squared over x squared, don't the x squareds divide out? We would have got 2. But unfortunately, we got 2x, which means it's linear, which means we have to know the y-intercept. And to get that, we have to do full-on synthetic division. Because we can't just say like non-horizontal. Like in 1010, we just said non-horizontal. Do you see it? No, they're like graph it. So we have to know the y-intercept. Okay, cool. Now we literally have a point. Let's go graph it. That might be all we need. Now, the hole was at what? -1, 0? So wouldn't that be right here? Isn't it also an x-intercept? And did it happen once, twice, 3 times? How many times did we see -1, 0? Did we? Look back at... Well, then we only saw it once. So it must cross true. Now, if you were like, wait, what? Let's do x and y intercepts. That's a like thing that always works. So you would say 0 equals x plus 1 over 2x minus 1. 2x plus 1. Let's do it. Let's just find some x-intercepts. So we would then from here, why did I only do the top? I'm asking again. For x-intercepts, why did I only do the top? Because the bottom multiplies up to 0. So aren't I getting x equals -1? -1, 0 as a whole? Yes, everyone? Which makes sense. It happened to be on the x-axis. And then we actually have another one, though. That might be helpful for graphing. Isn't -1/2 another one? And it also crosses through. They both cross through. They both only happen once. If this would have been squared or this would have been squared or what, you know what I mean, then we would have said it bounces. It's still an x-intercept. It just would have bounced. But these ones both cross through. So it's never hurtful to have another x-intercept. Was it -1/2? Do you want a y-intercept or do you guys, why not? Y-intercept, I go to standard form, which we had right here in highlighted yellow, because plugging in 0 is easier for that. So it'd be 0, 2 times 0 squared plus 3 times 0 plus 1 divided by 0 plus 2. Isn't that 0, 1/2? Okay, so over 0, up 1/2. Well, look, connect those pink dots. You can totally see what's happening here. So if I connect the pink dots, I'm crossing through that x-intercept, which means I'm headed to this pink dot. Aren't I crossing through that too? So then asymptote shape. So head to the asymptote. Head to your asymptote. Now go to your vertical. That's definitely not it. You've always got to draw both sides of the vertical asymptote. Go to this side of the asymptote. We said it needs to go in opposite. So doesn't that mean for sure we're going to be coming down like this, everyone? And then asymptotes shape. So then follow the asymptotes. Really, that one is basically as hard as it could possibly get. It had everything that could possibly go wrong, or like hard go wrong and hard. All right, so let's do this one. We can be done here soon, very soon. Let's just quick. Now we're going to go super quick. Here we go. We're going to go Crazy. Crazy quick. Factor the top. Pull out an x. Left is x squared plus 2x plus 1. Is that what it is? Oh, I like this one. There's just unique things that come up. Like you saw that last one. If we wouldn't have done that and you would have been thrown that one, you would have been a little bit like, wow. But now that you're seeing a lot of these things, you're going to be like more confident. Let's see. A times C adds up to be B. 1 multiplies to be 1 adds up to be 2. 1 and 1, 1 plus 1. Oh, yep, it does. So it factors to be x plus 1 times x plus 1. Like that. Then on bottom, we're factoring A times C adds up to be B. What multiplies to be negative 2 adds up to be negative 1, 1 and 2, negative 2. It quick factors to be x plus 1 and x minus 2. So then you start with vertical asymptotes and wholes. Vertical asymptotes don't divide out, wholes do. So what are we looking at here? Is x plus 1 a whole or vertical asymptote? A whole again. So you'd say x equals negative 1 is a whole. You then remove it. Ding, ding. And you, from here on out, the rest of the time, we're going to use the simplified equation. So I put a box around it to keep my brain looking in the right spot. So from here on out, I'm using that thing. So my whole isn't just at negative 1. It's at negative 1 some number. So we got to go plug in negative 1. So that'd be negative 1 times negative 1 plus 1 divided by negative 1 minus 2, which is negative 1 comma negative 1 times 0 over negative 3, which is negative 1 comma 0. So that's my whole. I'm going to write myself a note. Now look at this. Isn't this a vertical asymptote then? So then you would say x equals 2 is my vertical asymptote, and it goes in opposite direction. Since it happened one time. We then need our horizontal asymptote. Horizontal asymptote is leading term. Look at the simplified equation. What's the leading term? X squared, and on bottom x. When you divide that out, don't you get x? Crapola, it's a line. That's okay. No big deal. We just got to do it. So you have to have it in standard form. So x squared plus x divided by x minus 2. See, I distributed out, whoa. I distributed out the top so that I can do synthetic division. So we're using x equals 2 for synthetic division. 1, 0, 1. 1, oh, why did I put a 0? Was that crazy or what? No. Isn't it just 1, 1, 0? Because there's no constant and we fill in coefficients. We just got to make sure we have a coefficient for each piece, right? Add straight down, multiply up, add straight down, multiply up, add straight down. I don't need the final thing because that's the remainder. So y equals 1x plus 3 is our line. Our y-intercept is at 3, so go put it up at 3. Our slope is up 1 over 1, up 1 over 1, up 1 over 1. This is almost like the same level we just did. It's just now we're quick at it. Okay. Oh, wow, that line got off. But I'm not caring enough right now to refix it. Good enough. Now I need to get started. Well, we have a hole. What's the hole? Negative 1, 0. Isn't that right there?
Yeah.
It's an x-intercept, and it happened once. Now, if I want, I could get more points. But honestly, I feel confident graphing it with that because don't asymptote shape. So that means for sure we're headed to this asymptote, and then for sure we're headed to this asymptote. My other x-intercepts might not be accurate. They don't have to be. This didn't say what are the x-intercepts. We use that to graph accurately if we need it, but I don't care. Do you guys see what I'm saying? Like, that's what I know now, for sure, because asymptote shape. Jump to the other side of the asymptote, and shouldn't I be going up out of it? Because we said opposite. So then won't this shape me? And I'm done. Are you guys feeling confident in these? Not, I don't know.
Yes.
Okay, we won't do another one then because I think you guys got it. So I need you to go start actually practicing these on the homework so you can get help if you need it. I promise when you do it with someone, it really just is easier. So you've got to be able to do it alone without someone guiding your thought process. The only way you're gonna know if you can do it is a ton of practice. The only reason I'm this good at this is because of how much practice I've done. Even like the first 5 years of teaching, I wasn't as good at this. Not even close. So really, I promise, I'm just saying like a lot of people are like, wow, that's pretty easy. I get the gist of it. I'll be able to do that on the test. Nope, you're not gonna be able to unless you practice a ton. So you're now doing 3.3's homework. And you should be getting help on any 3.1, 3.2 problems from last time that you didn't know how to do when you got home and did homework.